What if we have three-dimensional arrays? Then how to interpret them? We'll see. Let's see this problem. Problem is like there is an array of 10, 20, 30 and row major order, and starting address of that array where it is stored is given in the memory, which is 5000, and integer size in machine is 4 bytes. Byte addressable system is the machine, that means every byte gets a number. What is the address of A of 765? How to understand it? So better we do this thing. For first dimension we give street, second dimension we imagine like apartments, and third one as flats. That means we have 10 streets, let's say. Each street has 20 apartments, imagine them, and each apartment has 30 flats. Okay. Now, but here one specialty is each flat is consuming again 4 addresses. The reason integer size is 4 bytes, byte addressable system. Then 1 byte gets 1 number, 4 bytes gets 4 numbers, and flat is in this interpretation is integer. Then every flat gets 4 addresses. If you remember that, we can easily solve it. So what is the address of 7th street? See, 765, right? 7th street, 6th apartment and 5th flat. That is what the question, right? But in row major order, before 7th street, all the previous streets are numbered. How many streets we have before 7th street? 0 to 6, which are 7. Then 7 streets are gone. Each street has how many apartments you see? 20 apartments, and each apartment has how many flats? 30 flats. Then each flat is consuming how many numbers? 4. Since integer size is 4, then these many addresses are already given. Okay, plus. Now once you do that, then we will come to our current street. What is our current street? 7th street. On that, our position is 6th apartment and 5th flat. Before 6th apartment, how many apartments will be there? 6. 0 to 6, correct? That's why I can directly pick this number this time. So that means this one, 6. So there are 6 apartments. Each apartment has again 30 flats, and each flat has how many addresses? 4. That's why 6 into 30 into 4, numbers again gone. Now once they go, then we will come to our current flat. Now we are at current street and current apartment, and now 5th flat ours. Before that, how many flats are gone? 5 flats are gone. That's why add 5 into each flat is consuming how many numbers? 4. Then overall numbers will be 7 into 20 into 30 into 4. If I compute it, it will be 27 the 140 into 120, whatever, doesn't matter, plus 6 into 30 into 4, that means 120 into 6, 720, plus 5 4 is 20. These many numbers. Then our number will be after this. That's why simply add to the starting address. What is the starting address of the memory? 5000 plus where your array starts plus this one. Okay, 720 plus 20, 740 plus 140 into 120. Okay, so 14 times the 140, 168. It will be 16800. If you simplify it, you get 16,800 plus so something, whatever. Okay, you simplify it, you get the answer. Answer is this one. This is the address. Now we'll see the second problem. What if the problem is column major order? Everything same. What if the data is stored in a column major order? Then what is the memory address of A567? We'll see that. Okay. Now A of 567 is the question, right? What is the address of this one? Since it is column major order, we should come from right to left. That means we are giving columns important. That's why 7 is a column, first column. That's why here we have to give the importance. That's why we say it as street. Okay. Now this is apartment as usual. This is flat. How many streets, apartments, flats we have? See, 10, 20, 30. Let me write the definition here. Int A of 10, 20, 30. In that, this is a storage capacity. That means total size. And that we have 30 streets, 20 apartments, 10 flats. Okay. So we are discussing column major order. Now to number, now we are going to number 7th street element. Before that, all the 7 streets are already gone. That's why. So how many numbers they consume? Which that 7 streets numbers 7 into what is the capacity of each street? To know the capacity of each street, we should come to the definition. In that you see every street has 20 apartments. That's why 20 apartments. Each apartment has 10 flats, right? So that's why finally 7 streets consume 7 into 20 into 10. So each flat is an integer. So we consumed, we calculated total number of flats, but we have to consume, find out the total number of addresses. So each such flat is consuming 4 addresses because integer is 4 bytes. So this is nothing but total numbers consumed by previous streets. Now we are in current street. Let me mark it. Okay, we are in 7th street. In that 7th street, we should go to 6th apartment. To go to 6th apartment, first of all, we have to go through all the previous apartments, which are nothing but 0 to 5, which are 6. So 6 apartments. Then these 6 apartments are already numbered. Then how many numbers they consume? So each apartment's capacity is 10 flats. So each flat capacity with respect to the consumption of the address is 4. So that's why these many addresses are gone. Now then we'll come to, so already we reached our street, our apartment. On that apartment, ours is 5th flat. Before that 5 flats are gone. Each flat is consuming 4 addresses. That's why these many addresses are gone. Then your address will become 5000 plus, since starting address 5000 plus this entire thing, correct? So that's why if you do 5000 plus this entire thing, whatever, so you get the answer. Okay. So this is all about calculations you can do. Okay.